Okay, so let's start talking about how to name these compounds. Okay, type 1 binary ionic compounds. And you can see that this pencil has popped up. So that means these are some good notes to write down. Okay, so let's talk about these words first of all, because it sounds kind of scary, but the word binary just means that you have two parts to something. So in this case, we have two elements. And for type 1 binary ionic, we have a metal and a nonmetal. So the two things that we have are a metal and a nonmetal. And because they're ions, they're called ionic. Okay, so that's all it means. Binary ionic means you have two things that are ions forming a compound. All right, and then the rules about how to name these things are just listed on the bottom of this slide. Step 1 is you write down the name of the metal, which is the cation, and you would get that off the periodic table from the metal section, either the first two families or the middle part, just the way it is on the periodic table. And then for the second part, for the nonmetal part, you would find the nonmetal on the periodic table and you would write down the name of it, except that you change the ending of it to IDE. All right, so let's do an example and then hopefully this will make sense. Whoops. So LiCl, we need to name that. So on your periodic table, you would find Li is lithium, and so you would just write down lithium, and then Cl is chlorine, and you would change the ending of it to chloride. So here is the name, lithium chloride. Li for lithium, and then chlorine becomes chloride. And that's all there is to it. That's all you do. Lithium chloride. Okay, and let's do this one. CaBr2. So Ca, find Ca in the metal part of your periodic table. I'll give you a hint. It's an alkaline earth metal. And then find Br. All right, and so the name of this one would be calcium bromide. So the metal, you just say the name of the metal, it's calcium, and the nonmetal is bromine. Change the ending to bromide. Calcium bromide. All right, one more example. AlF3. Al is our metal, F is our nonmetal. So I did forget to say that the metal is always written first. So Al is aluminum and F is fluorine. So this would become aluminum fluoride. Fluorine becomes fluoride, which reminds me of a great chemistry teacher song. Maybe we will play it for you sometime. All right, so that's pretty much all you do, okay? Before we're leaving here, I want to talk about these formulas for a second. Let's look at these formulas. So for example 1, lithium chloride, that formula has 1 lithium and 1 chlorine, okay? And the question is, why is that the case? All right, example 2, calcium bromide, had 1 calcium and 2 bromine. But we didn't say anything about the number 2 when we said the name. We just called it calcium bromide. All right, so what is that 2 in there for? All right, an aluminum fluoride. Again, there's 3 fluorines in that formula and 1 aluminum. But we don't say anything about the 3. We call this aluminum fluoride. Okay, so I'm just going to give you a quick little teaser for the next part. And we're going to look at these formulas. All right, so I got to switch over here to my camera. All right, so here's my camera. So for our first example, LiCl, if we find these things on our periodic table, all right, here's lithium right there. If you find its charge, it has a +1 charge. So I'm going to write lithium with a +1 charge. Chlorine is over here, and it has a -1 charge. So I'm going to go like that. And then we're going to do an activity with you, I think on Friday, using these puzzle pieces. So I'm just going to demonstrate this. Okay, here is a puzzle piece with lithium with a +1. And here's one with chlorine with a -1. So if I make a rectangle out of this, they match up perfectly. I've made a rectangle. And then the thing to note is that +1 and -1 adds up to 0, which is neutral. So when you have a proper ionic compound, it will have no charge. So the charges of the metal and the nonmetal have to cancel. So that's why for lithium chloride, we have 1 lithium and 1 chlorine in that formula. All right, let's do this again for calcium bromide. Example 2, calcium bromide. Okay, find this calcium on your periodic table. It is right here, has a charge of +2. So calcium is a +2. Bromine is a halogen, and it has a charge of -1, just like chlorine did. Bromine -1. So you'll do this, like I said, it's super fun, which is why I'm doing it. Calcium has a +2. Here's a piece with bromine. If I stick 1 bromine in there and I add those together, a +2 and a -1 does not equal 0. In fact, a +2 and a -1 equals +1. Whoops. Correct? So we need another bromine. Just like that. Now, if I have 2 bromines and 1 calcium, +2, and I add that to a -2, that equals 0, and I have a neutral ionic compound. Alrighty? So that's why I gotta have 2 bromines in my formula. All right, I'll do this one more time for the aluminum one. All right, example 3 was aluminum fluoride. I had 1 aluminum and 3 fluorides. Here is aluminum. It's got a +3 charge. Aluminum +3. Here's fluorine. Still a halogen, has a -1 charge. All right, if I try to use these puzzle pieces, here's my aluminum. If I just have 1 fluorine, and you add those together, +3 and a -1, that equals a +2. I'm trying to make it equal 0. If I put another fluorine in there, +3 -1, that equals a +1. So I got to have 1 more of these fluorines. So a +3 and a -3 equals 0. It's now neutral. So that is why I've got to have 3 fluorines. Okay, so that's it for me, and you can finish up those little Schoology questions, and that'll be it.